Hello everyone, October 21st. Alright, insert delete get random 01. 50% acceptance doesn't seem to be too hard. Well, I said it yesterday with that question and I got royally screwed. I mean, these type of things happen. You see a medium question, you're like, nah, it seems like easy, but sometimes it's not. But I think the general rule that I have witnessed is for these questions, medium questions, and the lower end, like the lower number, they tend to be they tend to be a little bit easier compared to the ones on the higher end because the inflation on the difficulty inflates. So because of that, a medium question like 900 or above will definitely be more difficult than a medium question, let's say 200-300, right? All right, when they implement a randomized set class. I like this type of question. Randomized set initializes an object, inserts an item into the set if not present, returns true if the item was not present, false otherwise. Removes an item from the set if present, returns true if it was present, false otherwise. Get random returns a random element from the current set of element. It's guaranteed that at least one element exists when this method is called. Each element must have the same probability of being returned. It must implement the functions of the class such that each function was in average 01 time completely. Can I use the random thing? Yeah, I think you can use the random library for this. Oh, value. Does this give us any hint? That's 32 bits. Well, we have that many calls. At least one element in data structure when get random is called. Okay, so randomized set insert 1, remove 2 shall be false, right? Insert 1. Remove 2, return false. Insert 2 is true. Get random shall return 1 or 2. And remove 1, which will be fine. And insert 2 already return false. Get random 2 is the only one return 2. Okay. What data structure are you thinking about? Well, it's a random set. Can we insert the same value? I mean, it could be a set, like a real set. It didn't say that each value is unique. Right? I didn't say. Oh, if not present, it's a set. So we do a set. Oh, we cannot. Can we do a set? How do you get value out of a set? You can't. At least in Python, you cannot get out of a set. It's very difficult to get out of a set. So if we do an array, then it'd be hard to determine. So it's going to be a dictionary, right? It's going to be a dictionary, and you push in because a dictionary you can. Wait, can we use dictionary to do this? Not really. A dictionary is the same as a set. I think the difficult part is to get a random value out of it. Let me think. Well, we'll push a value in. We can use a set, right? And then what? We need to determine which one to get. I mean, if we have an array, then the random will be easy. We just get a random one out of the array. And we can get it. No problem. What if the value we can... What if we store, let's say, a dictionary, right? but with indices? Or set with indices? Random. Get random has to be O1. If we store some data in it, right? If we store some data in it, and get random, we can get the index, and then we can use the index to check which number it is. But we have an issue. If it's in an array, then how do we remove? How do we remove? Because you can remove. But remove will give you a value, and you remove that value. Okay. So if you give me a value, and I remove it, right? That's fine. I mean, because the size, oh, that's actually, hold on, that's quite big. Interesting. Insert and remove, that signifies it has to be a set. But if it's a set, how do we get a random value from a set? I mean, we can have like two data structures, right? We can have a set, which handles the insert and remove. And we can have like an array to handle randomness. How do we use an array to handle randomness? Well, let me think. Insert is, yeah, insert and remove has to be, insert and remove has to be a set or a dictionary. I feel like I had to go to dictionary because a set is very limited on what it can do. A dictionary has something more, right? A dictionary, I can add something more to it. Maybe we can go that round. Get random returns a random element from the current set. If it's a dictionary, what do I put? I mean, if I give them an index, I can, right? I can give them an index, that's fine. But if I give them index, how do I retrieve? I cannot retrieve the index. I mean, it is for each value is given, can we find like a representation of the value that can be easily accessible? Yeah, it's hard to say. Insert. Each function average O1 time. Wow, this is not as easy as I had expected. Get random. Can get a random value. But how is the random value? If it's an array, right, and we push things in every time we add, I mean, that's fine. If it's an array, that's fine. But then I need to remove. I mean, I can get an array, a huge array, And that would be too big. The value is 2 to the 31st. So, get 1, get 2, and I say I want to remove 1. Okay, I have a set. I say, okay, I can remove 1. And after I remove 1, what do I do with the array? Do I just keep growing the size of the array? I mean, I can. Like, if I have a set, and I keep pushing, like every time add or remove, I do it on a set. And on the array, I just keep pushing. I don't delete. And every time it calls get random, I get a random one from the array. And if the value that comes out is in the set, then I'll return it. If it is not, then I do it again. I mean, that's possible, right? But eventually the array gets huge. If I insert tons, right, and then I remove tons, and eventually, like say the set only contains 1 value, but your array is huge, and then the probability of getting that specific one is low. So you probably have to do it multiple times. How do we handle this then? Do we make the array dynamic as well? Like in O1, sorted, but it says has to be O1 in runtime. Even if I was thinking about the sorted array. It's not going to work. Even if it's a sorted array, it's not going to work. What we need is a set that is, that's asking too much. And we need a set that I can access. I can do random access on a set. Jeez. I remove or no, it's not gonna work. Huh. Inserts. I probably got stuck. Hold on. Let's see if I can get my mind outside of this. What other data structure can we use for this? Random, right? That's the point. We got stuck on random. What are other ways we can get something random out of a collection of objects and have the same probability of being returned? A random so we start with an array. Why I keep thinking about array? Because array is a way to get random. That's how I know. Right? Or hold on. Can I get? This might be a cheat. Hold on. I was going to let's see. Random. Nah, that's a cheat. I don't think that's what the question is talking about. But I think Python. Maybe I can use like get random from. I think there's a function called what? Choice, right? There's something called choice. Choice. There you go. Choice. Return a random element from a non-empty sequence. If sequence empty, and the choice is return more. Can I do choice? Can I do choice out of a? Do choice out of a set? I mean, this is just like to get the question. I'm pretty sure that's not what the intention is. Oh, come on. Let's see, from random import choice. Let's do a set. Let's do a set 1, 2, 3, 4. Man, if it's possible, then choice A. Nope, no, it's not subscriptive. Yeah, exactly. That's why set cannot be used for a random access. It's not subscriptable. All right, so no, that's not the way to go. All right. It says on average O1 time, right? Which means not exactly O1 for each operation. So we have a little bit leeway. We have some leeway. An average O1 time, and each function needs to work O1. The choice only works for array, and get random does not delete it, right? It just return a random element. So if I only insert, and get random, then it's fine. We can use an array. That's perfectly fine. So it only happens when you remove. Can we make remove work better? Can we? Well, we cannot remove things. Well, how about this? I keep inserting, right? And then whenever it calls remove, I record which value is removed, right? I record another array, or maybe a set, or whatever, will record which one is removed. And then I look into the array, and we see if the value to be removed is like at the end, what that's maybe it will be at the end, so I can pop it out. Close it. Let me pop it like, it could be like a deck. So if it's the front or the end, and I can pop it out. But if not, I just have this value remove, right? And then when we call random, I get a choice, or I get a value out, and I compare to the remove, see if it's inside remove. If it is in remove, then I choose again, right? And I can have like a little of balance. I mean, if the remove set gets huge, right? If the remove set gets huge, then that means it's a high likelihood that we can delete. So it's like housekeeping, right? Like some procedures we will just do, like we don't care. Like if the array is huge and the remove call is small, then we don't care. We only care when the remove gets big. Because when the remove gets big, then the likelihood of actually getting the right element is small. So when the remove gets big, we need to manage. We need to manage the array. How is this going to work? When do we do housekeeping, right? If we go this idea, then we need to do housekeeping. Let's say when if the remove reaches, hold on, let's think about this. If I have an array of size 10, if I have size 10 and I have one value from this is removed, right? And then the likelihood of I getting a random value from this array is going to be, well, I'll get one. So there's a likelihood, like a 1 in 10 likelihood, right? A 1 in 10 likelihood that a 1 in 10 likelihood that the value I get out is the one to be removed. Can we do something? If I find a value, I just say we do, oh, look at this. Look at this. I have an array of size 10, right? And every time when I want to get a random value, I do randint. I get a random index for this. So from 0 to 9, I get a random index. And I check the array, and if the array value is not the one to be removed, then just return that. Perfect. If the array value is the one to be removed, right, then I can say that position is open, right? That position is open, which means the next value can be inserted into that one directly. So we're not increasing the size of the array. This might work, right? So when we insert, we just keep inserting, and when we remove, I mean the get random part, we solved that already because it's an array, so we can also always get random. So we need to solve is how do we do remove? So we insert, and when we remove, we know the value we need to remove. Oh, but by the way, we need a set. So we need oh my god, how many do we need? We need an array for the randomness. We need a set to handle insert and remove, like just the return value of insert and remove. And we need another set to record all the values that has been removed, that require to be removed. Right? So we have a set that is the current, we're going to call it the current set, and another set called the removed set. And the removed set contains the value that's supposed to be removed, but is currently not removed from the array, right? And then we keep inserting, and when we remove, we will remove from the current set, that's fine, and then we can handle the return value or whatnot. And then we add that value to the removed set, right? To the removed set, but we don't touch. We do not touch the array. And the array will keep growing. And then every time when we get a random value from the array, right? I get a random value from the array. If the random value comes out is the ones to be removed, then we just do it again, right? We just do it again. And as we are doing it again, we also will set another let's say, another array that will record all the positions in the array that is now empty. So the next time when we insert, we can insert into one of those positions. Right? So the array will not grow like if we keep deleting, right? If we keep removing, then we'll just record which one. But it's still possible. Like if we keep deleting, if we keep inserting, right, and we keep deleting, like we insert say 10,000 values, right, and I delete 10,000, and they delete 9,999 of them. Then each time I delete, yeah, I can say like each time I delete, right, I can just randomly choose one value and see if that matches, right? Because the difficulty that we have is, but then still, if I do that, now the whole point is to, the whole point, the whole point is to reduce the size. Because I have, if I go insert 10,000 and then remove 9,999, and the array will still have 10,000 in size, right? It'll still have 10,000 in size. The array still have 10,000 in size. How do we handle that? Well, we can take a random out of 10,000, but the likelihood of actually hitting the value is low. What if we can set up a scheme that each time we get a random value, it will always have more than 50% chance to get the actual value? Can we do that? Well, we can say as the array grows, right? As the array grows, then and as more is removed, and each time it's removed, then the likelihood of getting the value that we want decreases until the point when more than half of the array is removed, right? More than half the array is removed. If that is the case, what do? We need to manage the size, right? We need just to manage to make sure at least more than half of the array is the one that's currently inside the array. So how do we? Well, it's an array, then we can only pop, right? We can pop, which means if we have more than half of the array, if we have half the array that is to be removed, right? If I have half the array to be removed, then we check on the last element to see if that one is to be removed. If it is, we just pop, right? We pop it. We can actually keep popping until, so because it will be a 50-50 chance, right? So in the last position will be 50 chance if it's a, so we just, if it is not, then we just swap. We just keep reading until we find one, and then we swap, and then we pop. And then we keep reading, and we swap, and then pop. Swap and pop. Now, if the goal is to always keep more than 50%, that is, yeah, if I have more than 50% of chance to get the value that is in the current set, then we only need to do like what, 2 rounds, at most 2 rounds, right? If it's more than 50%, then at most 2 rounds we can get the one that we want. And if it grows more than 50%, we just use the trick to pop. Oh, I'm gonna try this. This seems to be a very convoluted way, but I have no confidence. This seems to be tough. But we're gonna try. Oh, I need to ST this. All right, let's see. So the whole point is I will keep the array size, right? I'll keep the size. But if we do this popping thing, right, then it's okay, right? And it's okay. We just maintain the array always more possible to get the actual value than the removed value. Then we don't need to keep the index. Well, do we still do that? If we random it? Yeah, we can, right? If we random it, like, that'd be like two things are going on, right? We will actively keeping the size in check so that at least more than half of the elements in the array is the true values, right? And then because this maintenance, I'll always keep it at, let's say, minimum, like only do once, only popping one, right? Only popping one to make sure more than half is in it. So if every time we do random and then the ones to be deleted came out, then we also record that index. So the next time insert, we can put that one in. All right, now thinking about what would happen if we insert 10,000 and remove 9,999. All right, so first time remove, we don't care. Second time remove, we don't care until we remove to a certain point. All right, remove 5,000. Right, when we hit 5,000 mark, then the next remove, we'll run the scheme to delete the to pop the array, right? We'll pop the array, and yeah, we just go from the end, find the first one that is empty. If the last value is empty, we just pop it, and then we can keep going, right? And we want to delete again, and we'll look for the next one. If it's not, then we just keep looking for the one that is. Then we swap them, then we pop. So that's what happens when we do delete, right? When we do delete, we're going to compare the size, right? Compare the size of the current and the to be deleted. We compare the size of the two, and if the current is only one more than to be deleted. So we need a current to be one more than a delete. So if the current one is one more than a delete, that means if we delete, then the balance will be thrown off. So when that happens, we will actually delete one of the values, right? We'll actually delete one of the values. So it'll be two mechanisms, right? We have two mechanisms going on. Oh, this is convoluted. I don't think it's gonna work. I have no confidence in this. So what do we need? We need a current. We need a current set. That is going to be a set. We need a to delete set. That's going to be a set. We need a list. That's going to be a list. And we also need a empty indices. Oh, and the empty indices might need to change as well, because if we actively shrinking the size, the empty indices need to shrink as well. Okay, so empty indices, that's going to be a set. Okay, so insert. Insert is easy. Insert is just if val in self.current set, then return false. All right. Elsewise, self.current set add val, and we're going to say for the empty indices, right? So we're going to say, how do we get one value out of the set? Now that's the difficulty of using set. I mean, we can loop it and then just do once, and we kill it, and then we remove it. Yeah, that's fine. What if you use that as an array? Well, thing is, if we use that as an array, because we want to control the size of the list, we want to control the size of this, then we might need to remove. So no. So we just say for empty indices in self dot this, so we can loop it, and we just say we say self.list ei, right? Ei equals val and break. Else, if we don't find anything, if there's nothing empty indices, then we say self.list.append val. Okay, so that's that. Remove, a little bit typical. Let's get random first. So we need random. So from random import randint. Right. So we're gonna say the while true, right? Because we don't know, and we say index equals randint. Randint is inclusive, right? Randint is inclusive. So we just say 0 to len self.list -1, right? So we get the index, and we need to check if self.list index is in self.toDelete set. Why do we need to delete set? We don't need, right? We just say if it's not in current set, that means that one is to be deleted, right? We don't need to say, yeah, why do we need self.toDelete set? What's the purpose of this? There's no purpose, right? There's no purpose. As long as the value is not in current set, then that means it's to be deleted. So we just say if this is not in self.current set, right? If it's not in current set, I don't think we need this, right? If it's not in current set, that means this value is to be deleted. So we need to say self.emptyIndices.add index, right? But we ignore it, and we'll basically say continue, right? So if this, I'm gonna do this, we're gonna go back. Else, if this is in self.this, then we return, right? Then we return return self.list index, right? We don't have to return anything else. So no true or false on this. Returns a random, yeah, it's just an int. It's no true or false. So we're just gonna go at most 2 times. That's the idea. At most 2 times we will get this. Okay, now we're gonna do remove. And we don't need this. Right? I don't think we need this. How do we do remove? Well, first of all, right, to remove, first of all, we remove from the self again. If now every time we call remove, we will do something. All right, we'll do something. So we can easily say the return is going to be self dot no. Let's say if val is in self dot current set, then self dot current set dot remove val and return equals true. Else return equals false. This is just to get a return value, and we set this, right? Now we're gonna handle the list and empty indices. So we're gonna say on the size, right? So the size of current set, if the size, we say if len current set is smaller or equal to len self.current set. Smaller or equal to self.list, right? If that means the actual, the real values is smaller than what we have, that means we need to remove, right? We need to remove. So we just look at the last one, right? We say, we'll find the first one, and we need to, okay, so we say for I in range, and we're going to say from n minus 1, from len self.list minus 1, and then minus 1, minus 1, right? And we need to find the first one. We say if self.list I is not in self.current set. So that's the one that we need to delete, right? That's the one that we need to delete. And when we find it, and we just swap, we say self.list I and self.list minus 1 or equals to self.list minus 1 and self.list I. So we're swapping the ones to delete, list minus 1, no minus I. So we're swapping I and minus 1, and after do that, we break. We only do it once, right? Once we've done it, then we simply say self.list.pop. So we're popping. Oh, but we also need to know, so when we swap, hold on. So I is the one, so we don't want, right? And then we swap it. And that means I is now something that we might want, right? Something that we might want. Then we need to update the empty indices, right? We need to update the empty indices. So basically we say if I, sorry, we swap, and we say if I is in self.empty indices, self.empty indices dot remove I, because it might no longer be an empty index. It's no longer an empty index. And if len self.list minus 1, because we are popping the last one, so we'll do this one as well. If this is in self.empty indices, then self.empty indices dot remove len self.list minus 1, right? So we update self.empty indices. So we update that, we find it, we break it, and then we pop. And once we pop, because we compare smaller or equal to, so when we pop, the current set will be larger. Oh, it's not, it will always small, it's divided by 2, right? It has to be divided by 2. So we want it to be smaller or equal to this one divided by 2. But if we want to do this, why don't we? Yeah, it's because if we make this one too small, too close to current set, right? Then we'll have to go through a lot more to find. Yeah, so we make it on this, and we only pop once. So we say if this is smaller or equal to this one divided by 2. Well, we can actually, if it's even number divided by 2, then remove it first, right? Remove it, and then equal, that's like, no good. I want to make self.list smaller. But it need to be smaller by 1. All right? I might get 2. I think that should be fine. And let's just leave it at this, right? And now we pop. And we pop, go back, and once it's equal to, once it's larger than this one divided by 2, then we say that's good. So it won't go more than like maybe 2 rounds, 1 or 2 rounds. And we're going to return, right? Ret. All right, let's give this a shot. Mamma mia. If this one passes, I'll be very happy, but it's just based on how convoluted this is, I'm not overly confident. Oh man, I think we have some logic error to begin with. What? Insert output is false. Wait, what? My insert is wrong. Wait, insert return true if it's not present. Oh, I didn't return. I didn't return true. I need to return true. I return false, I didn't return true. Remove, I have true or false. All right, try it again. Oh, when no return, evaluate to. Okay. I don't know, I'm gonna try. Let's try it. Oy, oy, oy. Let's see how this one goes. Oy. Pop from empty list. Okay. Why do you do pop here? All right. Why do you pop here? I mean, we can do pop inside. All right, we do pop inside. If this is and then we do this and blah blah blah. But before we break, right, we do pop. Let's do pop in high here, and it'll be that like this. Right, you know what? Let's just do it here. It's better visually. All right. Yeah, we'll pop. Let's pop here. I'm gonna pop here, and of course we do return. I forgot to return earlier. So return true. All right. Try it again. Just with this test case. Now we have two test cases. Try it. Okay. Try it again. Judging. Oh, we got it. Oh, wow. Huh, this scheme works. Ay. This scheme works. But 14%, so it's a pretty terrible scheme. And look at the memory usage. So no, this is a not. This is a not. Oh my god, look at the next challenge. Duplicates allowed. Oh. All right. Let's see how fast regular people get. Ay. Twice as fast. Twice as fast. Oof. I mean, it worked. All right, it worked. This scheme worked, but it's definitely not the best. All right, so let me say this scheme worked. I am very surprised and happy at the same time. Okay, so what do we say? So the idea is, I shouldn't say this. This scheme requires a list in order to do get random. All right, I can't think of another way to do it. Right. Now the problem with a list is that remove will take on to complete. Right? Remove will take on to complete. So insert will not affect. Insert is not affected. So to reduce the time complexity of remove, we implemented. Now we use. How should I say it? We need a compromise. So we need a compromise, right? A compromise. So the compromise is like this. The compromise is this. The compromise is this. If the current set, if the size of the current set is much larger, it's more than half of the size of the list, right? We simply don't remove anything. If we don't remove anything from the list when a remove call is made. This is because when the current set is, this is because we have more than 50% chance of returning a true value, right? Return a true value. So it's because we have more than 50% to return true value. Now, when the size of the current set drops at or below half of the size of the list, that's when we need to do some housekeeping, right? Do some housekeeping. Basically, we need to pop from the list the values that are not supposed to be there. Now, since we have built up to a point, right? Built up to a point where the number of values to delete in the list is half, right? Is half the list's size. It will take a very short traversal to locate one to be deleted. So we locate one to be deleted. So we locate one to be deleted, swap it with the tail of the list, and then pop it. By doing this, we will ensure that the probability, right, the probability of obtaining a random value from the list that also exists in the current set is always more than 50%. Right? Now, in addition to this, we also implemented a scheme to replace the values in the list that are supposed to be deleted. This scheme works like this. When a random value generated from the list is not in the current set, we record its index such that the next time a value is added, we don't append to the list, but put the new value in one of the indices, one of the empty indices. This is another way. This is another way to actively inflate the number of true values in the list. So I would say on average, insert always takes 01. On average, remove and get random will take O2, right? O2. Actually, yeah, we'll take get random will take O2. On average, get random will take O2 because the likelihood of obtaining the true value is larger than 50%. On average, remove will take a little bit longer, I think. Remove will take, well, it's also actually, now remove also take, on average, get random and remove. Both will take about O2 because the likelihood of obtaining the true value is this. Okay, so I didn't do very well. 8, so we have 875 milliseconds. So 14%. All right, let's take a look at how the smart people solve this. Hash map list swap last element when remove. Are they doing this all the time? Get random, insert. That's the push, If we can replace, then we replace. Wait, hold on. To do remove index. Okay. I remove this if wait, what are you saying? I add the hash map is okay. So to remove index, I say if the remove index is the last one, then I simply in the last val to remove index, and I pop. So they only pop it once. Wait, this work? I think it's a similar idea, but they do it much less often, right? But how? How do you make sure this will always give you the right value? Because you only remove once. Oh, I see. Oh, I see. Ah, makes sense. Oh, I see. So every time a value is to be removed, I can always swap it to the end. We are on the right track, but just so close. It didn't get there. Yeah, I know what they're looking for. I know exactly what to do now. Okay, let's try it again. Oh, yeah. We're here. We do exactly the same thing, swap, right? But it's at every single time. Every remove we can do this. So this is from, copy the link. Heap it. This is from HIEPIT, heap it. We're so close. We are so close to the actual solution. to the smart solution. The key point is to always remove the value, from the list, and we can do so by first remembering each value's index, right? Each value's index, and when we remove, we simply swap the to remove value to the end of the list and then pop it. Right? By doing this, we ensure that at any moment, the list always contains all the values in the current set. But of course, the current set is not going to be a set. I want to call it current dict. It's going to be a dictionary. We do need this. We don't need this. So I'm going to insert eval in. Oh, I need to change. Hold up. Let me change current set. Boom, 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 all the way to current dict. And if it's in it, we'll return false. Otherwise, self.list append val and current list val equals self.list -1 size len this -1. Now that's the new indices, right? And then return true. This will be easy. This will be just choice. Right? So you can just return self.choice, self.list. For removal, if a val is not in this, then return false. Right? Otherwise, when you do a little bit of swapping, that's not self.current set. Oh no. Ah, shoot. I called the wrong thing. I got the wrong thing. It's here, man. Return self.choice, self.list. Alright. We need to change this, right? So if this val is not in this, return false. And then what? And then we need to check its indices, right? So we need to swap. So index will equal to self.currentDict val, and I'm going to pop from this first. That's fine, we can pop it from, so self.currentThis.remove val, right? And then we say self.list index self.list -1 equals self.list -1 self.list index, right? So we swap the two, and then self.list .pop. And then this one will return true. All right, try this scheme. I mean, this means like my analysis was correct as well initially. All right. Let's see. Key error. Oh my god, return, immediate return. Come on, man. That was not right. I don't know why I say self.choice. It should be just choice. Dict has no remove. Wait, did not remove? Is that delete? Ah, come on. Delete from a dict. Is it's pop. Del statement. Del statement, my bad. It's del statement. So it's del, delete this val. All right. Okay. Let's try it. See. What the hell? What? Insert 0, insert 1, remove 0, insert 2, remove 1. Huh. Hold up. Something is not right. Okay, I'll come back here. It's about remove, right? Because when I do this, this is correct. Because I don't go bigger, so always -1. And then when I remove, right, vowels in this, I get the index. Okay, that's good. And I delete it, right? And then for this, I do a swap. And once we do a swap, I'll pop. How is this not right? Debug. So let's print, right? Print val and self.list. Let's see what's going on. So 0, 1 is not deleted. Oh, 1 is not deleted. Insert 2. 2 gets deleted. 1 is not deleted. Suspicious. Very suspicious. So insert 0. Oh, hold on. I think I know. Insert 0, right? And then I insert 1. Then I remove 0. Then 1's index need to change. I didn't change. I did not change. Which means somebody's index need to change. Okay, so it's fine, and then we need to change self dot current dict self dot list -1. Right, so that index is no longer this. That index is going to be index. At this line. Try it. Oh, I don't need to print it anymore. Yep, now we're right. Now we're right because we need to change the index because the last one gets swapped, right? So the last one's index need to change. All right, try this one again. Pending, judging. Oh, gosh. Oh, it's a different issue. It's insert. How? Output false. Need to be true. I removed it. Insert. What the hell? I hate this. We have issue with insert. Yeah, let's try print value and self.current dict. For the last insert, I have something in there, which is weird because we just removed it. All right, so we have we call remove. If not in, we return false, and then we insert, which is this call. Then I inserted. All right, I inserted it, and I return true, which is correct, and then get random 0, and I remove. So val is 0, 0 is in, so index is this. Screw me. Because 0 is at the end. If I remove it first and add it again, yeah, so we have to change it and then delete it, because it's possible the ones to be deleted is the same one. All right, it's possible. Because if the end one needs to change. All right, let's go through the logic again. So we get the value, get the index that needs to be removed, and then we change the ones that supposedly not removed to that index, and then we do this, and this basically is a no op. Okay, let's try this one. Oh. All right, this is my mistake. I have a print statement. I'll run it one more time. I have a print statement. Jeez. Yeah, this is... I never had this before. Output limit exceeded. How many output is allowed? Oh, wow. Allows a lot. There we go. There we go. This is the one. This is the one. This is the one. Oh, there's still tricks, right? There's still some tricks. Must update the index, right? The index before removing from self.current dict, because it is possible that the value to be removed is already at the tail, at the end of self.list. All right, that's a good question. Very good problem. I like it. Well, we did do it, but it could be better. We're very close. All right, that'll be it today. Well, I got somebody asked me if I would do this consistently. Well, I am consistent every day, but not exactly at the same time. Right? It depends. It depends on like how busy I am. But I also don't. I don't recommend you guys watching this live because I talk slowly, and I think the best one will be if you guys want to watch. You can watch it the next day, double speed. That's how I like to watch. But I try my best to do around 12 p.m. Eastern time, but sometimes things happen, and then I don't have a set schedule for this. All right, anyway, I'll see you guys tomorrow then. Adios.